All right, so today we're going to be going over Module 17.3, which is combining transformations of quadratic functions. So our first activity says exploring quadratic functions in the form g of x equals a times x minus h squared plus k. So we know the k is what goes up and down. So the k is going to be what moves it up and down, and then that h right here is going to be what goes right or left. So there's always a sequence of transformations that's going to move the parent function, which is y equals x squared. So we want to go from f of x equals x squared to g of x equals 2 times x minus 3 squared plus 1. So when you graph the first one, it's a stretch factor of 2, because this 2 right here tells you it is vertically stretched. And it's positive, so it's going to have a minimum and it's going to open facing up, just like it is on that graph. Now we have to translate the graph to the right, and that negative 3 says it's going to go 3 units to the right, and this 1 is going to say it's going to go up 1 unit. So yeah, it's going to be right here. So it's going to go to the right 3 units up 1. So from here, the vertex of the original is at 0, 0, and then the vertex of the new one is at 3, 1. So for number 2, it says, using the equation g of x equals 2 times x minus 3 squared plus 1, find g of 4. So what we're going to do is we're going to plug a 4 in for our x. So it's going to be 2 times 4 minus 3 squared plus 1. So 4 minus 3 is 1. 1 squared is 1 times 2, 2 plus 1, 3. So now it says, is 4, 3 the curve you plotted? Yes. So we'll have 4, and then 1, 2, 3. So since it is symmetrical, see how it's 1 to the right and 2 up, so it's going to go left. So your graph will look like that one. So it's more narrow than the original parent function, and it goes to the right 3 units and up 1. So using the equation for number 3, is 5, 9 on that curve you plotted. So our x is 5, y is 9. So we're going to plug in 5 for our x. So it's going to be 2 times 5 minus 3 squared plus 1. So 5 minus 3 is 2. 2 squared is 4. 4 times 2 is 8. And then 8 plus 1 is 9. So is 5, 9 on that curve? Yes. So you can do the same thing with 4. Now we're going to talk about graphing these. So to graph the quadratic function of the form g of x equals a times x minus h squared plus k, first identify the vertex, which is hk. So it's going to be whatever is here. That's going to be your x, and then your k is what goes up and down. That's going to be your y. So next, consider the sign of a. So your first step is going to be find the vertex. So by looking at this equation, our vertex is going to be negative 1, negative 2. So negative 1, negative 2. And I really hate when they go to the left by 1s and then up and down by 2s, but you just have to look for that. So the vertex is at negative 1, negative 2. So then all you have to do is just make a table. So start plugging in some numbers. So you have negative 1, negative 2. I would do 1 or 2 to the right and 1 and 2 to the left of that vertex. So we're going to have 0 is always an easy one. 0 plus 1 is 1. 1 squared is 1. 1 times negative 3 is negative 3. Negative 3 minus 2 is negative 5. So you can plot those points. So all you have to do is just start plugging in some numbers. Once you have the vertex, it makes it a little bit easier. So if you look at number 6, it says list the transformations of the graph of the parent function in the order you would perform them to obtain the graph of the g of x equals negative 3, x plus 1 squared minus 2. So first step you're going to do is find your vertex, which is going to be at negative 1, negative 2. Then your next point, so you have a -1, -2. So the next is going to be find a couple before and a couple above. So I would do like -2, -3, 0, and 1. Then you have to find your next xy coordinates and then graph it. And just by looking at that -3, it's going to be a little narrower than the parent function, and it's going to open going down since that's negative. If that was positive, it would open going up. All right, so we'll let you guys, we can do number 9 together. So number 9. First thing you're going to do is find your vertex, which is going to be at 2, 4. So our vertex is right there. Now we have 2, 4. So we want to find, so we'll go 1, 3. I'll just do 3 of them just to go a little quicker. So we're going to plug in a 1 for our x. 1 minus 2 is going to be -1 squared plus 4. So -1 squared is 1 times -1. So it's going to be -1 plus 4 is going to be 3. So we'll have 1, 3. Then you're going to do the same thing with a 3. So 3 minus 2 is 1. 1 squared is 1 times -1. So it's going to open up going down. I would probably throw a 4 in there. So that's also going to be 3. And then we're going to have 4 minus 2 is 2. 2 squared is 4. So we're going to have 4, 0. And it will open going down. So you guys can go ahead and try number 10. All right, so the next one is going to be writing a quadratic function given a graph. The graph of a parabola can be used to determine the corresponding function. So basically, you have to still follow the same steps, except there's going to be a little substitution. So a house painter standing on a ladder drops a paintbrush, which falls to the ground. The paintbrush's height above the ground in feet is given by a function in the form of f of t equals a times t minus h squared plus k, where t is the time in seconds since the paintbrush was dropped. So use the graph to find an equation for f of t. So our end goal is going to be finding an equation. It's going to look like f of t equals, we want to find the a, t squared plus k. So right now, just by looking at the graph, we know the k is 30 because it's going to be right there. So we can already fill that in with 30. So all we have to do is just solve for our a. So your first step is going to be the vertex of the parabola is hk, 0, 30. So our h right here is going to be 0, and our k is going to be 30. So that's where we get f of t equals a times t minus 0 squared plus 30, or a times t squared plus 30. Now this is the step 2. This is the only new part that you're going to have to do, and you have to take one of the points. And I would always try and find the number 1, because it'll make your calculations a little easier. So what you're going to do is you can see that f of 1 equals 14. So substitute 1 for t and 14 for f of t. So this right here, the f of t, is going to be 14. So it's going to be 14 equals a times the t was 1, since those are the same exact things. So it's going to be 14 equals a times 1 squared plus 30. And then when you solve that, you get a is -16. So then that's what we're going to put right there. So -16. So when you rewrite it, it's just going to be f of t equals -16 t squared plus 30. And then it just says estimate how much time elapses before the paintbrush hits the ground. You can just look here and say it's a little before a second and a half, so about 1.4 seconds. So that, okay. So yeah, if you take a look at number 12, it says a diver jumps off a cliff into the sea below to search for shells. The diver's height above the sea in feet is given by a function in the form. There's your form. So the first thing you want to do is find your vertex, which is at 0, 40. And if you look up here, your vertex is HK. It's also in your notes that I have for you. So your H is going to be 0, and your K is going to be 40. So if you look here, we'll have f of t equals a times t minus h squared plus k. So our vertex was at 0, 40. So f of t equals a times t minus 0 squared plus 40. Now, by looking at that, you know that one point that we have is 124. So when your t is 1, your f of t is 24. So we're going to put a 24 here. A times t is your 1 minus 0 squared plus 40. So now, since a is the only variable, that's what you have to solve for. So it's going to be 24 equals a 1 minus 0 is 1, squared is 1. So a plus 40. And then minus 40, negative 16 equals a. So now we know what our k is already. We're going to use that, and we're going to use this. So when you rewrite it, it's going to be f of t equals negative 16 t squared plus 40. And that's the equation for number 12. So that would be the equation for number 12. So there's only one more thing that we have to do, and it's just modeling the height of an object in free fall. And we're going to use our graphing calculator for that, or Desmos. So it's got the little calculator symbol up there. So the quadratic function h of t equals negative 16t squared plus c can be used to approximate the height. So if you look at the example 3, all you have to do is plug these into your graphing calculator or Desmos. So I've already plotted these in Desmos, and I don't really want to zoom out too much, but I put in the h of t equals negative 16t squared plus 64 in the upper left, and that's the red one. The blue one is negative 16t squared plus 144. So all you have to do is just look at where these cross the x-axis. So the red one crosses at 2 seconds, the blue one crosses at 3 seconds. And that's all you have to find there. So if you look at number 14 on your book, so if you look at number 14, it says 2 baseballs are dropped, one from a height of 16 feet and the other from a height of 256 feet. Write the 2 height functions. So you're going to have h of t equals negative 16 t squared plus 16. Then you'll have the next one is the same exact function. So you can do f of t if you want. So f of t equals negative 16 t squared plus 256. Now to find out how long it takes each baseball to hit the ground, go to Desmos. So instead of 64, we'll put 16. Instead of 144, we'll go 256. So we'll zoom in a little bit. So the red one, you can't have negative time, so don't even look at to the left of the y-axis. So the red one takes 1 second. So the 16 feet, it only takes 1 second. But the blue one, when it's up 256 feet, takes 4 seconds. So use Desmos if it can definitely help you out. All right, well, that's all I have. If you have any questions, please reach out, email, join the Zoom chat on Wednesdays, and I can help you out. Thanks a lot. Bye.